welcome to this video about the IUPAC system of nomenclature for complex compounds, specifically alkanes when no functional group is present. When naming complex alkanes, we need to follow a set of rules outlined by the International Union of Pure and Applied Chemistry, that is IUPAC, to ensure that each compound has a unique and systematic name. So let us delve into further about IUPAC system of nomenclature of alkanes without functional groups. Here are the IUPAC naming rules for alkanes. Rule 1, longest chain rule. The first step in naming a complex alkane is to determine the longest continuous carbon chain in the molecule. See here, the first step in naming an organic compound is to select the longest continuous chain of carbon atoms, which may or may not be straight. This continuous chain is called parent chain or main chain. The other carbon chains attached to it are known as side chains or substituents. On the basis of number of carbon atoms present in the parent chain, the parent normal hydrocarbon is named. Here, root word is decided on the basis of the number of carbon atoms present in the parent chain. Here is an example. You can see this is one alkane. Okay, so in naming this alkane, first we have to select the parent chain, which contains maximum number of carbon atoms. Okay, so if I select this as the parent chain, then it contains only 4 carbon atoms. Instead, if I select this as the parent chain, it contains 5 carbon atoms. So this is the parent chain and contains 5 carbon atoms, and the root word is pent. 5 carbon atoms means it is pent. So this is the derivative of pentane, and here is one side chain also called as the substituent. It is the methyl group. Okay, so this one is the derivative of pentane. Here is another example for selecting a parent chain. Okay, so this is one alkane. First we have to select the longest chain in this alkane. Okay, I have already told you that the parent chain may or may not be straight. Suppose if I select this as the parent chain, see here, it contains 1, 2, 3, 4, 5, 6 carbon atoms. Instead, if I select this as the parent chain, then it contains 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. So this is the wrong selection of parent chain. Okay, so we have to select this as the parent chain, and the remaining side chains, here 2 methyl groups are there and here 2 methyl groups are there. These are called substituents. So in the parent chain there are 8 carbon atoms. The root word is oct. That means this compound, this alkane, is the derivative of octane. Okay, here is another similar example, that is example 3. This is an alkane. In this alkane, the first step is to select the longest continuous chain of carbon atoms, and this longest chain of carbon atoms may or may not be straight. Suppose if I select this as the longest chain, see here. So if I select this as the parent chain, it contains only 6 carbon atoms. Instead, the same molecule, if I select this as the longest chain of carbon atoms, then it contains 7 carbon atoms. So this is the wrong selection of parent chain, and this one is the right selection of parent chain in this molecule. And the remaining side chains here, CH3 group is there, and CH2 CH3 means it is methyl group, and this is ethyl group. Okay, so in the longest chain of carbon atoms, that is in this parent chain, there are 7 carbon atoms. The root word is hept. That means this alkane is the derivative of heptane, and the complete IUPAC name will be given later. Here we are learning only how to select the parent chain. Okay. Here is one note. It is possible that sometimes there may be 2 or more carbon chains of equal length in the molecule. In such a case, the selected chain should contain maximum number of side chains, that is substituents. So here is an example for this. This is an alkane, and in this 2 possible ways are there for selection of parent chain. That is, 2 carbon chains of equal lengths are available for the selection of parent chain in this molecule. See here, we can select this as the parent chain or this one as the parent chain. Both have the equal lengths. At that time, which one should be taken as the parent chain? See here, if I select this as the parent chain, the number of side chains to this parent chain is 2 here. One methyl group is there and one ethyl group is there. So 2 substituents are there in this selection. If I select the carbon chain this as the parent chain, isn't it? So in this case, there is only one substituent. So in both cases, 2 carbon chains are having the same length of 5 carbon atoms. In this case, 2 substituents are there, but in this case, only one substituent is there. And in this type of situations, we have to select the carbon chain containing the maximum number of side chains. That means between these two, we have to choose this as the parent chain. Okay. So this is the correct selection of parent chain, whereas this one is the wrong selection. And one more example you can see here. Okay. In this, 2 possibilities are there. That means 2 chains of carbon atoms having equal lengths are possible for the selection of parent chain. So if I select this as the parent chain, 1, 2, 3, 4, 5 carbon atoms are there in this chain. If I select this as the parent chain, then the number of substituents is 1, 2, 3. So 3 substituents are there for this selection. And if I select this as the parent chain, straight one as the parent chain, then only one substituent is there. So which one we have to choose here as the parent chain? We have to go for this one. isn't it? So here two carbon chains of equal lengths are possible. At that time, we have to select the parent chain that contains maximum number of substituents. So the chain of 1 is chosen as the parent chain because it has 3 substituents. Okay, so this one is the correct selection and this one is the wrong selection. Example C, see here. One more example here I am explaining about the selection of parent chain when two chains of equivalence are possible. So if I select this as the parent chain, 1, 2, 3, 4, 5, 6 carbon atoms are there in this. Okay, then the number of side chains it contains is 1, 2, 3, 4. That means 4 substituents are there for this selection of parent chain. And if I select this as the parent chain, see here, same lengths are possible. Here 6 carbon atoms, in this also 6 carbon atoms are there. Okay, and if I select this as the parent chain, then the number of substituents is 1, 2, 3. Only 3 substituents are there. So we have to go for this selection only. The chain of 1 is chosen as the parent chain because it has 4 substituents. Okay, this one is the correct selection and this one is the wrong selection of parent chain. Next, rule 2. Numbering of carbon atoms of the longest chain. After selecting the parent chain, the next step is to assign numbers to the carbon atoms in the chain. The carbon atoms of the longest continuous chain, that is parent chain, are numbered by Arabic numerals 1, 2, 3, 4, etc. from one end to the other. Okay, so let us see what is locant. The number that locates the position of the substituent is known as locant. So while numbering the carbon atoms in the longest chain, that is in the parent chain, and here are certain rules. Rule A. The carbon atoms carrying the first substituent get the lowest possible number. The position of the substituents, that is side chains, are indicated by the number assigned to the carbon atoms to which it is attached. See here, here is an example. This is the parent chain. Okay, and we can assign numbers to the carbon atoms in this parent chain either from left to right or from right to left. So here I am assigning numbers from left to right, 1, 2, 3, 4, 5. If I assign the numbers from left to right, the carbon atom to which the substituent methyl is attached has got number 4. So here this is the locant. The number that locates the position of the substituent is known as locant. So in this case the locant is 4. And if I assign the numbers to the carbon atoms from the right to left like this, the locant is 2. Okay, so if only one substituent is there, it should be given the lowest possible number. The carbon atom to which it is assigned should be given the lowest possible number. So this is the wrong numbering and this one is the correct numbering. Okay, and this is the complete structure of IUPAC. And here is the root word. Depending upon the number of carbon atoms in the longest chain, root word is decided. If only 2 carbon atoms are there, it is eth 3 carbon atoms prop like this, and we have suffix. There are two suffixes, primary suffix and secondary suffix. You can see here actually there are 11 parts in the IUPAC structure. And number means 1, 2, 3, etc. That is to which carbon atoms in the parent chain the substituents are attached. They are indicated by these numbers. And if more than one same substituents are attached, at that time di, tri, tetra, that is numerical designations are used. And in case of primary suffix here, depending upon the nature of the saturation, we have to use these suffixes. If only carbon-carbon single bonds are there, we have to go for ane. Carbon-carbon double bonds are there, we have to go for ene. And if that compound has at least one carbon-carbon triple bond, then that is ine. The primary suffix is ine. And here are the secondary suffixes, same numbers and numerical designations repeat here. And this is the functional group, isn't it? So the functional group plays more and more important role while giving the IUPAC name. Okay, if only carbon and hydrogen atoms are there in the organic compound, the secondary suffix is only E. OH alcohol, CHO aldehyde, all these will be learnt in the next coming videos, because we are not going to use any functional groups in this video. And before the root word we have prefixes. Primary prefix is there and secondary prefix is there. And this primary prefix is used only for cyclic compounds, that is when carbon atoms form ring-like structures. At that time the primary prefix we have to use is cyclo. And in all other cases, if cyclic compounds are not there, this primary prefix is ignored. And secondary prefixes, these are nothing but substituents, halides. If fluorine is present, fluoro, chloro, bromo, iodo, like this. And if alkyl groups are there, methyl, ethyl, propyl, like this. And among these functional groups, they can be used even as secondary prefixes also. If NO2 is there, it is nitro, NO, nitroso, like this. So these are the secondary prefixes which are attached to the carbon atoms in the parent chain, depending upon the position of the carbon atom to which these secondary prefixes are attached, isn't it? They are named like this. Okay. So this is the complete IUPAC structure, and it contains 11 parts. And here this is the correct numbering of this alkane, because to the second carbon atom methyl group is attached, and this carbon atom has been given the lowest possible number if the carbon chain is numbered from right to left. Okay, so what is the root word for this? So in this carbon chain there are 5 carbon atoms, so the root word is pent. Next, what is the primary suffix? In this carbon chain only single bonds are there, so it is when single bonds are there, the primary suffix is an, and secondary suffix is e, because only carbon and hydrogen atoms are there, no other atoms are present in this molecule, so the secondary suffix is e. Next, primary prefix won't come because these carbon atoms are not forming a ring-like structure. It is a straight chain only. open chain only, not closed one. So we will not use this primary prefix, we ignore this. Next, secondary prefix. Here one methyl CH3 group is attached to this, so it is secondary prefix is methyl. So to which carbon atom this methyl group is attached here, it means second carbon atom. So the IUPAC name of this organic compound, this alkane, is 2-methyl pentane. Okay, so between the number and the name we have to give one hyphen. Okay, 2-methyl pentane, this is the complete IUPAC name of this structure. Okay. Subrule B, under numbering, in case there are two or more similar substituents attached to the parent chain, their positions are indicated separately by the prefixes such as di, tri, tetra, etc. That means if two similar substituents are attached to the carbon atom in the parent chain, then we have to use the prefix di. If three are attached, we have to use tri. These are the numerical designations. Okay. So when more than one substituents are attached to the carbon atoms in the parent chain, we have to follow the numbering rules as follows. The first one is lowest set of locants rule. Lowest set of locants rule. The set of locants which, when compared term by term with other locant sets, each in order of increasing magnitude, has the lowest term at the first point of difference. For example, you see here the locant set 2, 3, 6, 8 is lower than 3, 4, 6, 8 or 2, 4, 5, 7. So here this is one locant set, that is in the parent chain to these carbon atoms substituents are attached to the second carbon, third carbon, sixth carbon, eighth carbon, like this. Okay, so we know what is locant. The number that locates the position of the substituent is known as locant. So this is one locant set. And if we compare these locant sets, suppose if I compare this locant set with these locant sets, term by term in the increasing order of their magnitude, this locant set is lower than these two. That means you have to compare term by term. See here, set 1, 2, 3, 6, 8. Set 2, 3, 4, 6, 8. If you compare these two sets term by term at the first point of difference, by looking at the first point of difference only, we can say which locant set is lower and which locant set is higher. So if you compare these two terms 2 and 3, 2 is less than 3. At the first point of difference, 2 is less than 3. That means set 1 is lower than set 2. This set is lower than this set. Similarly, you can see here, I am comparing this set again with this set 2, 4, 5, 7. So at the first position, these two are same. That is, the first two locants are same. Here the position of the first substituent is same, that is 2 only. Then we have to compare the second locants 3 and 4. So 3 is less than 4. So at the first point of difference, 3 is less than 4, isn't it? So set 1 is lower than set 2. So this rule is called as the lowest set of locants rule. Okay. When two sets of numbers are equally possible, then the order of the prefixes in the name decides which shall be used. That means if numbering is done, we got the two sets equal. At that time, the order of the prefixes will decide the numbering. For example, you see here 1 bromo 3 chloropropane and not 3 bromo 1 chloropropane, because chloropropane. So here alphabetically B comes first. That means the carbon atom to which bromine is attached should be given the first number. Next chlorine. Okay. So when two sets of numbers are equally possible, then alphabetical order will decide the lowest set of locant rule. Okay. Another rule that is used for numbering the carbon atoms in the chain is lowest sum rule. Okay, this is the second one. When many substituents are present, the numbering is done from the end whereupon the sum of locants is the lowest. And here are some other rules. See, if there are different substituents attached to the parent chain, their names are written in the alphabetical order. And in case there are different substituents at equivalent positions, then numbering of the parent chain is done in such a way that the alkyl group which comes first in the alphabetical order gets the lowest number. Just now we have seen it. So while explaining some problems, we can use all these rules. At that time you can better understand. Okay, so these are the rules which are used for naming alkanes, IUPAC rules. Now let us do some examples here. Write the IUPAC names of the following compounds. Here is one alkane. Okay, so we have to give the IUPAC name for this alkane according to the rules we have discussed so far. So here is a solution. This one is a given alkane, and first we have to select the parent chain. This one is the longest chain of carbon atoms. So this is the parent chain. After selecting the parent chain, we have to give the numbers to the carbon atoms in the parent chain. First, here I am numbering the chain from left to right, 1, 2, 3, 4, 5. Similarly, I will do the numbering from right to left also. Which one is correct? To know this, just now we have discussed two rules. One is lowest set of locants rule and another one is lowest sum rule. Okay, so let us verify which one is correct. By using both rules, I am going to explain it. First, lowest set of locants rule I am using here. See here, from left to right, to which carbon atoms side chains are attached, second and third. So the locants, the first locant set is 2, 3 from left to right. Set 1, left to right, 2, 3. Set 2, from right to left, third and fourth carbon atoms are attached methyl groups, that is 3 and 4. If you compare these two sets term by term, that is 2 is less than 3 at the first point of difference only. No need to compare all other terms. At the first point of difference, 2 is less than 3. That means set 1 is lower than set 2. So the locant set 2, 3 is lower than 3, 4. That means numbering from left to right is the correct one according to the lowest set of locants rule. So let us verify the same by using lowest sum rule. Okay, see here, sum of locants from left to right, 2 plus 3, 5. From right to left, 3 plus 4 is 7. So 5 is less than 7. So the first one is correct. That is, numbering from left to right is correct. Okay. Now, what is the root word for this? In the parent chain, there are 5 carbon atoms. It is pent. Root word is pent. Primary suffix is an because only single bonds are there. So an. Secondary suffix is e because there are only carbon and hydrogen atoms in this compound. So e. And secondary prefix, it is methyl. 2 methyl groups have been attached to the second and third carbon atoms. So methyl. So the IUPAC name of this compound is 2, 3. These are the numbers. Di, it is the numerical designation 2, 3 dimethyl pentane. Okay. Next, let us write the IUPAC name of this compound. So same chain is same here. Parent chain is same. Here is the solution given problem. So I am numbering from left to right after selecting the parent chain, right to left. So let us check which one is correct by using lowest set of locants rule and lowest sum rule. Lowest set of locants rule. So from left to right, set 1 locants are 2, 4, 4. To the second carbon atom and to the fourth carbon atom, methyl groups are attached. So 2, 4, 4, because here I am repeating the number 4. Methyl group is attached 2 times here. Okay. Next, from right to left, 2, 2 and to the fourth carbon atom. So if we compare the lowest, that is set of locants by term, isn't it? 2 is equal to 2, and at the first point of difference 2 is less than 4. That means set 2 is lower than set 1. So this one is wrong and this one is correct. And let us go for the lowest sum rule. From left to right, 2 plus 4 plus 4 we get 10. From right to left, 2 plus 2 plus 4 we get 8. So lowest sum rule also same in this case. So we have to give the numbering from right to left. Giving the numbering from right to left is correct. So remove this. Now root word is pent, ane, e, and secondary prefix is methyl. So how many methyl groups have been attached? 3. So 2, 2, 2, 4. Totally 3 methyl groups have been attached. So it is a trimethyl pentane. Okay. Next, third problem. See here, this is the parent chain. I am numbering from left to right. Let us number from right to left also, and we have to check which one is correct. Numbering from left to right is correct or from right to left is correct. We can verify by using 2 rules: lowest sum rule and lowest set of locants rule. Okay. So first, let us take lowest set of locants rule. From left to right, locants are 2, 3, 5. Okay, set 1 locants are 2, 3, 5 from left to right, set 2 right to left 2, 4, 5. This one is correct. If you compare these locants term by term with these locants, here first terms are equal, then we have to go for the second terms. 3 is less than 4. So at the first point of difference 3 is less than 4. So 2, 3, 5 is lower than 2, 4, 5. So this one is wrong. Similarly, let us verify it by using lowest sum rule. Sum of locants 2 plus 3 plus 5 10 and 2 plus 4 plus 5 11, right to left. So this one is correct. So in both cases, left to right numbering is correct. So what is the root word here? The root word is it contains 1, 2, 3, 4, 5, 6 carbon atoms. So hexane. So 2, 3, 5 trimethyl hexane. This is the IUPAC name of this alkane. Next, here is the problem number 4. See here. Solution. Now, first we have to select the parent chain. If I select this as the parent chain, 1, 2, 3, 4, 5, 6, 7 carbon atoms only it contains. If I select this one as the parent chain, then we have 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. Only 7 are there. So this is the wrong selection of parent chain. Now I am going to select this as the parent chain. So in this 8 carbon atoms are there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. After selecting the parent chain, we have to give the numbering from either way. 1, 2, 3, 4, 5, 6, 7. Let us give the numbering from this side to this side. 1, 2, 3, 4, 5, 6, 7, 8. So from left to right, lowest set of locants rule I am using. Which one is correct? Set 1 left to right. If numbering is done from left to right, third carbon atom contains 2 methyl groups. For that reason 3, 3 and here 7, 7. From right to left, you see here second carbon atom contains 2 methyl groups, so 2, 2. Here sixth carbon atom contains 2 methyl groups. Okay, so if we compare these two locants sets term by term, at the first point of difference only 2 is less than 3. That means set 2 is lower than set 1. So this is the correct one. This is the wrong one. And let us verify the same by using lowest sum rule. Sum of locants from left to right 3 plus 3 plus 7 plus 7 it is 20. And from right to left 2 plus 2 plus 6 plus 6 you get 16. So 16 is smaller than 20. So assigning the numbers, the carbon atom from right to left is correct. Okay, so remove this. Next, then what is the root word? 8 carbon atoms are there in this chain. So root word is oct. An, E, primary suffix is An, secondary suffix is E, and the secondary prefix is methyl. So 2, 2, 6, 6, tetramethyl octane. 2, 2, 6, 6 tetra, 4 methyl groups have been attached to the parent chain. So tetra methyl octane. It is evident from the above examples that both the lowest set of locants rule and lowest sum rule give the same results when the length of the carbon chain is not very long. However, when the length of the carbon chain is long, the two rules give different rules. Up to this it is okay. When the length of the parent chain is small, two rules are same. Two rules will give the same result. But when the length of the carbon chain is very long, at that time the two rules will not give the same result. Then we have to go for the lowest set of locants rule. Lowest set of locants rule is more preferable than lowest sum rule. Okay? Hence, that set of locants rule is preferred which has a lower number at the first point of difference, even if it violates the lowest sum rule. Okay, so whenever these two rules are not giving the same result, then we have to rely only on the lowest set of locants rule, even though it violates the lowest sum rule. That is, lowest set of locants rule is more preferable than lowest sum rule. Okay. Here is one problem. This is the given problem. We have to give the IUPAC name for this alkane. So this is the parent chain, obviously, because this is the longest carbon chain in this compound. So let us give the numbering from left to right. At first, totally 10 carbon atoms are there in the parent chain, and I am doing the numbering from right to left here, and later I will verify which one is correct. So I am going to verify which one is correct by using the two rules, that is lowest set of locants rule and lowest sum rule. Lowest set of locants rule. So set 1 left to right, third carbon atom and fourth carbon atom and ninth carbon atoms have been attached methyl groups, substituents. So 3, 4, 9 are the locants from left to right. From right to left, 2, 7 and 8. And if you compare these two sets term by term, at the first point of difference 2 is less than 3. Then you no need to compare the remaining terms. At the first point of difference 2 is less than 3. So this is wrong selection, wrong numbering. This one is the right numbering. Suppose if you want to check the same, which one is correct, by using the lowest sum rule, sum of locants from left to right is 3 plus 4 plus 9, 16. And sum of locants from right to left is 17. So actually, according to lowest sum rule, numbering from left to right is correct. 16 is less than 7. So 16 we are getting from left to right. So numbering from left to right is correct according to this rule. So here two rules are giving the different results. At that time we should not use lowest sum rule, and we have to prefer only the lowest set of locants rule in order to verify which one is correct. So the set of locants rule is preferred which has a lower number at the first point of difference, even if it violates the lowest sum rule. So don't use this rule whenever two rules are giving different results. So do not use this. Okay, so I am going to use this only. So the IUPAC name is, you can see here how many carbon atoms are there. There are 10 carbon atom. The root word is 10, AN, E and methyl. So the IUPAC name is 2, 7, 8 trimethyl decane. Okay, 2, 7, 8. Here is a problem number 6. This is an alkane, isn't it, containing many side chains or substituents. 4 substituents are there. So let us name this compound. Solution: this is the given compound, and first we have to select the parent chain. This one is the parent chain. Okay, I am giving the numbering from left to right, and let us give the numbers from right to left also, and we have to decide which one is the correct. Two rules are there for this. Okay, the first one is lowest set of locants rule I am using to determine which one is the correct numbering. Set 1, left to right, the locants are 2, 5, 6 and 6, because sixth carbon atom, isn't it, it contains 2 methyl groups, so the number should be repeated: 2, 5, 6, 6. This is the set 1, and set 2 from right to left: 3, 3, 4, 7. Okay, these are the two locants sets. Now we have to compare these two locants sets by term we have to compare. So at the first point of difference only 2 is less than 3, so you no need to compare the remaining terms. When at the first point of difference 2 is less than 3, then this set 1, that is assigning numbering from left to right, is correct. This is wrong. If you want to decide the which numbering is correct, either from left to right or from right to left, let us use the lowest sum rule. Sum of locants from left to right is 2 plus 5 plus 6 plus 6. We get 19. From right to left we get 17. 3 plus 3 plus 4 plus 7. So according to this rule, numbering from right to left is correct. But according to this rule, numbering from left to right is correct. That means two rules are giving two different results. At that time, we should not use lowest sum rule. We have to go for lowest set of locants rule, because lowest set of locants rule is more preferable than lowest sum rule. So do not use this rule. Okay, so numbering from left to right is correct. Remove the numbers from right to left. Then root word: in this parent chain, how many carbon atoms are there? There are 8 carbon atoms. The root word is oct. Primary suffix is an and secondary suffix is e. Secondary prefix is methyl. So 2, 5, 6, 6 tetramethyl octane. This is the IUPAC name of the given alkane. Okay, so let us do some more problems related to this in the next coming video. Okay, thank you.